Assalamualaikum warahmatullahi wabarakatuh. Hi everyone.
Hello everyone.
Back again with Heaven Group. So in this video, we are going to explain about the use of derivative function in economics. But before we start, let us start with introducing ourselves. My name is Andi Putri Ahira.
My name is Audriana Septiani
My name is Dayana Anissa
from Heaven Group.
From Heaven Group.
My name is Denzel Sudjono from Heaven Group.
From Heaven Group, International Management Class, Faculty of Economics and Business Untan.
So in this video, I'm in charge of explaining functions of production and partial elasticities.
In this time, I will explain about producer profit, joint product, and the example question.
Explain about price discrimination and multiplier effect.
And I'm in charge to explain about the practice question.
Producer profit. In economic terms, producer produce goods to get the maximum profit. Due to the maximum profit is the goals, they will determine the level of the output. This profit is difference between all the receipts and the cost that must be paid in the manufacturing process. The profit is maximum when the difference between the revenue and the cost is the maximum. There are three requirements of profit maximization. First, marginal revenue equal to marginal cost. Second, the gap between the marginal revenue and the marginal cost is the widest. Third, marginal cost lower than marginal revenue. The formula is profit equal to TR minus TC. TR is total revenue and TC is total cost. Now move to the producer profit exercise question. First, noun the demand function P equal to 250 minus Q and the TC is Q power 2 plus 50Q plus 400. Determine the amount of the unit that creates the maximum profit and how much the maximum profit. Noun P equal to 250 minus Q and the TC is Q power 2 plus 50Q plus 400. First, we gonna find the amount of the unit that creates the maximum profit with the formula MR equal to MC, but MR and MC are unknown. So we can get the number by this method. P equal to 250 minus Q. So we can get the TR by multiple the Q and the P. So TR equal to Q multiple open bracket 250 minus Q. And the result of TR is 250Q minus Q power 2. MR is the first derivative of TR. Therefore, MR is 250 minus 2Q. And the TC equal to Q power 2 plus 50Q plus 400. So, MC is 2Q plus 50. After find the MR and MC, we using the formula MR equal to MC to find the amount of the units that create the maximum profit. MR equal to MC. So it is 250 minus 2Q equal to 2Q plus 50 minus 4Q equal to minus 200. Q equal to minus 200 divided minus 4 and the result is 50. So the units of maximum profit are 50 units. Q equal to 50 units. So we substitute Q into TR and TC function. TR equal to 250 multiple 50 minus 50 power 2 and the result is 10,000. TC equal to 50 power 2 plus 50 multiple 50 plus 400, and the result is 5,400. Now TR minus TC, it is 10,000 minus 5,400. So the maximum profit is 4,600. There are 4 joint cost allocation methods. The sales value method allocates joint cost based on the relative sales value of each product at the split-off point. This method also ensures that joint cost allocated to each product will not exceed sales revenue for each product, unless total joint costs are higher than the total revenue. Second, physical unit method. The physical unit method is usually applied to joint products which are similar in stat and have a standard unit of measurement. Third, contribution margin method. Under the contribution margin method, the joint cost apportionment is done through the marginal costing technique, where the contribution can be understood as the surplus of sales over the variable cost. Moreover, the variable cost is determined with the help of units sold, and the fixed cost is ascertained through the contribution margin ratio. Fourth, average unit cost method. The average cost per unit is calculated by simply dividing the total cost of all the joint products incurred before the splitting off by the total of the number of units produced altogether. The question is, PT Sejahtera Coconut Oil is a company which engages in the oil industry. At the same time, it can produce coconut oil, coconut milk, and coconut water. The joint cost needed for produce coconut oil is 1,500,000 rupiah. The process of joint production creates 7,500 liters of coconut oil, 4,500 liters of coconut milk, and 3,000 liters of coconut water. The selling price of each product per liter at the split-off point is coconut oil 7,000 per liter, coconut milk 4,000 rupiah per liter, and the coconut water 2,000 rupiah per liter. Calculate the allocated cost. For the coconut oil, the sales value is 52,500,000 rupiah. It is get from the quantity produced multiplied by the selling price per unit. The relative sales value is 68.63%, and the joint cost allocation is 1,029,4,500 rupiah. For the coconut milk, the quantity produced is 4,500 liters, and the selling price per unit is 4,000 rupiah. So the sales value is 4,500 liters multiple 4,000 rupiah, and the result is 18 million rupiah. The relative sales value of coconut milk is 23.53%, and the joint cost allocation is 352,950 rupiah. For the coconut water, the sales value is 6 million rupiah. The relative sales value is 7.84%, and the joint cost allocation is 117,600 rupiah. So the total of sales value are 76,500,000 rupiah, and then for the joint cost allocation, the total is 1,500,000 rupiah. Next, joint products. Joint products are two or more products that are produced together by using the same material, labor, and overhead costs. These costs cannot be separated for each product, and each product has a selling value or quantity that is relatively same.
Price discrimination happens when a firm charges a different price to a different group of consumer for an identical goods or service for reasons not associated with cost of supply. Price discrimination takes us away from the standard assumption in that there is a single profit maximizing price for the same good or services. There are three types of price discrimination. First degree price discrimination or perfect price discrimination involves the seller charging a different price for each unit of the good in such a way that the price charged for each unit is equal to the maximum willingness to pay for that unit. Second degree price discrimination or nonlinear pricing occurs when price differ depending on the number of units of the good both but not across consumers. Quantity discount or premia are the obvious examples. Third degree price discrimination means that different purchasers are charged different price, but each purchaser pays a constant amount for each unit of the good both. This is perhaps the most common form of price discrimination. Examples are students' discount or charging different price on different days of the week. If the monopolies face two markets, namely A and B, while TRA in the bracket QA plus TRB in the bracket QB is the total revenue from the markets A and B, and the total cost of production for goods sold in both markets is TC in the bracket QA plus QB, then profit earned by this formula. In order to get the maximum profit, there are first order terms, you can use this formula, and second order terms, you can use this formula. So this is the examples of price discrimination. Hence, we can see that the marginal revenues for markets A and B are different when the elasticities of demand at a single price are different. Further, we also find that the MR of the market with a higher elasticity is higher than the MR of the market with a low elasticity of demand. A monopolist in such a case transfers some amount of product from market A to market B. This is because in market B, the high elasticity of demand implies larger marginal revenue. It is important to note here that when units are transferred from A to B, the price in A will rise and fall in B. However, there is a limit to which the monopolist can transfer between markets A and B. Once he reached that limit and reached a point where the MRAs in both the market become equal due to the transfer of output, transferring more will no longer be profitable. At this stage, the monopolist starts charging different price in the two markets, so he charged a higher price in the market with a lower elasticity of demand and a lower price in the market with a higher elasticity of demand.
The equation for functions of production in general is written as Q equals to f of x1, x2, x3, and so on. The output Q is also called total physical product or TPP. TPP curve is defined as a curve that shows total production rate or Q at different level of variable input usage, and the other inputs are considered fixed. Another curve that can be derived from TPP curve are marginal physical product or MPP curve and average physical product or APP curve. MPP curve is a curve which indicates additional TPP due to the additional use of one variable input unit. Average physical product curve or APP curve is a curve showing the average yield per unit of variable input at different levels of use of that input. For example, from a production function, known the average is APP equals to 100x minus 2x squared. Determine the magnitude of MPP when the uses of the input x equals to 30. How much is the MPP when the APP is maximum, and how much is the total production in those two circumstances? So the APP equals to 100x minus 2x squared. So the form for APP is APP equals to TPP divided by x. But because we are looking for the TPP, it will be TPP equals to APP times x. We insert the APP, which is 100x minus 2x squared, times x. So the TPP is 100x squared minus 2x cubed. Now, the questions also look for the MPP. The form for MPP is actually MPP equals to dTPP divided by dx. But because we're looking for the MPP when the APP is maximum, so the MPP will be equal to APP. So MPP equals to 200x minus 6x squared, because the derivative of the TPP, which is 100x squared minus 2x cubed, is 2x minus 6x squared. When the x equals to 30, then the MPP is 200 times 30, because the x is 30, so it will be 200 times 30 minus 6 times 30 squared. The result will be 6,000 minus 5,400 equals to 600. So the MPP is 600. Now we are going to look for the total production at those two circumstances. When the APP is maximum, then the first order derivative is the APP divided by dx equals to 0. When the APP is maximum, the APP divided by dx equals to 100 minus 4x, because the derivative of 100x minus 2x squared is 100 minus 4x and equal to 0. After that, we are going to simplify it so that we can find the x. So we move the minus 4x to the left, so it will be 4x equals to 100, x equals to 25. For the second order derivative is d squared APP divided by dx squared smaller than 0. So the second order derivative of APP is minus 4. Because minus 4 is smaller than 0, then when x is 25, APP is maximum. So for x equals to 25, then MPP equals to 200 times 25 minus 6 times 25 squared. The result will be 5,000 minus 3,750 equals to 1,250. The value of total production, or TPP, is for x equals to 30 is TPP equals to 100 times 30 squared minus 2 times 30 cubed equals to 90,000 minus 54,000 equals to 63,000. And for the x equals to 25, the TPP equals to 100 times 25 squared minus 2 times 25 cubed. The result will be 32,250. So the result will be 31,250. Functions of productions of Q equals to f of x, y is often analyzed for a certain output level. So f of x, y equals to constant. The curve is called isoquant curve. Isoquant curve is a curve that shows possibilities of combination technique between two variables to produce certain level of output. Isoquant is being used to produce certain amount of output with minimum total cost. There are three needed information. A is a quant for a specific output level. B is price of input X, and C is price of input Y. The price of X and Y are used to determine the cost to produce certain output level. The cost of producing the output can be indicated by the equation C equals to Px times X plus Py times Y. C is the cost, Px Py is the price of input X and price of input Y, and X, Y is number of input X and Y used. A production function shows the equation of Q equals to XY, the price of input X or Px equals to 5, and the price of input Y or Py is 4. What is the minimum cost of a manufacturer must spend to produce 500 units? So the isoquant or the XY equals to 500. From the isoquant equation, we can get that X equals to 500 divided by Y. After that, we insert all the numbers into the isocost equation. So the equation is C equals to Px times X plus Py times Y. So it will be 5 times 500 divided by Y plus 4 times Y. The result will be 2,500 divided by Y plus 4Y. In order to get minimum cost, then dc dy equals to 0. The dc dy is equals to 2,500 divided by y squared plus 4. After that, we have to simplify the numbers in order to get the y. So y squared equals to 2,500 divided by 4. Y squared equals to 625. So y equals to 25. So when the y is equal to 25, then x equals to 500 divided by 25 equals to
20.
So the cost to produce 500 units is 5, C equals to 5 times 20 plus 4 times 25 equals to 100 times 100. The cost will be 200. And now the second order derivative is bigger than 0. To prove that the d squared c divided by dy squared is bigger than 0, then equals 2 times 200 are 2,500 divided by y4. Because we multiply everything to 2 equals 5,000 divided by y4. So for y equals to 25, then d squared c divided by dy squared bigger than 0, then it means that the c is minimum.
Another important concept related to functions of production is the elasticity of production. The elasticity of production measures the degree of sensitivity of the amount of output changes in one of the factors affecting it. By definition, the elasticity of production is the percentage of change in the amount of output produced due to a change in the use of input with 1%, or mathematically can be formulated as E equals to partial Q with respect to X times X divided by Q, or E equals to partial Q with respect to Y times Y divided by Q.
Production function shows the equation of Q equals to 4xy minus x squared, where Q is the output, X and Y are the inputs used. How much is the production elasticity for X and Y if the input X used is 1 unit and the input Y used is also 1 unit? So for X equals to 1, Y equals to 1, then Q equals to 4 minus 1, because 4 times 1 is 4 minus x squared, x minus 1 is 1. So Q equals to 4 minus 1 equals to 3.
So the Q is 3. Production elasticity of input X or EX equals to partial Q with respect to X times X divided by Q. So partial Q with respect to X equals to 4y minus 2x, because the partial derivative with respect to x of 4xy minus x squared is 4y minus 2x. So after that, for y equals to 1 and x equals to 1, the partial q with respect to x will be 4 times 1 minus 2 times 1. It will be 4 minus 2 equals to 2. So the partial q with respect to x is 2. Now, we input all the numbers that we have calculated into the production elasticity of input x, or EX equals to 2 times 1/3. The result will be 2/3. After we look for the production elasticity of input x, we have to find the production elasticity of input y, or EY, equals to partial q with respect to y times y divided by q. With respect to the partial derivative of q with respect to y of equation 4xy minus x squared will be 4x. So for x equals to 1, then partial q with respect to y equals to 4, because 4 times 1 is 4. So the EY equals to 4 times 1/3 equals to 4/3. The elasticity obtained from the questions above means that if the input x change into 1%, then when the input y uses for 1 unit, the output will change for 2/3%. Same goes for the production elasticity of input y. If the input y change for 1%, then when the uses of input x for 1 unit, the output will change into 4/3%.
Every time there is an injection of new demand into the circular flow of income, there is likely to be a multiplier effect. This is because an injection of extra income leads to more spending, which creates more income, and so on. The multiplier effect refers to the increase in the final income arising from any new injection of spending. The size of the multiplier depends upon household marginal decision to spend, called the marginal propensity to consume, or MPC, or to save, called the marginal propensity to save, or MPS. It is important to remember that when income is spent, the spending becomes someone else's income, and so on. Marginal propensities show the proportion of extra income allocated to particular activities, such as investment spending by UK firms, saving by households, and spending on imports from abroad. So this is the examples of multiplier effect. If 80% of all new income in a given period of time is spent on UK product, the marginal propensity to consume would be 80 divided 100, which is 0.8. The following general formula to calculate the multiplier use marginal propensities as follows: 1 divided 1 minus MPC. Hence, if consumers spend 0.8 and save 0.2 of every €1 of extra income, the multiplier will be 1 divided 1 minus 0.8 equals 1 divided 0.2 equals 5. Hence, the multiplier is 5, which means that every €1 of new income generates €5 of extra income.
For number 1, the question is, if the production cost of X refrigerator per day is 1 per 4x square plus 35x plus 25 million rupiah, and the selling price per unit is 50 minus 1 per 2x million rupiah, then how many refrigerators must be produced every day to earn the maximum profit? So, function of production cost x is 1 per 4x squared plus 35x plus 25. And the function of selling price x is x times 50 minus half x equals to 50x minus half x to the power of 2. Profit x equals to function of selling price x minus function of production cost x, which is equals to 50x minus 1 per 2x squared minus 1 per 4x squared plus 35x plus 25. The total is negative 3 per 4x squared plus 15x minus 25. To make it maximum profit, we have to derive the function of profit x, and the function must be equal to 0 so that it can become maximum. So the derivative of profit x equals to 0. Derivative of profit x equals to negative 3 per 2x plus 15, which means negative 3 per 2x plus 15 equals to 0. So 3 per 2x equals to 15. And then we can get x equals to 15 times 2 per 3, which equals to 10. For number 2, the question is a company knows the demand function of a market A and market B. If the demand function in market A is PA equals to 80 minus 5QA, and the market B is PB equals to 180 minus 20QB, and the cost function TC equals to 50 plus 20QA plus 20QB, find the total quantity and the price for a maximum profit and find the maximum profit. To find the maximum profit, total revenue equals to price times quantity, which also means total revenue equals to PA times QA plus PB times QB. Total revenue equals to 80 minus 5QA times QA plus 180 minus 20QB times QB, and equals to total revenue is 80QA minus 5QA squared plus 180QB minus 20QB squared. Pi equals to total revenue minus total cost. Pi equals to 80QA minus 5QA squared plus 180QB minus 20QB squared minus 50 plus 20QA plus 20QB, which means the pi equals to 80QA minus 20QA minus 5QA squared plus 180QB minus 20QB minus 20QB squared minus 50. The derivative of pi per derivative of QA equals to 60 minus 10 QA. Derivative of pi per derivative of QB is equals to 160 minus 40 QB. To find the maximum, the derivative of pi equals to 0, which means 60 minus 10 QA equals to 0, and 60 equals to 10 QA. So we get the QA is 6. And for QB, 160 minus 40 QB equals to 0. So 160 equals to 40 QB, and we get that the QB is 4. Now that we have found the quantities, we can find the price. PA equals to 80 minus 5 QA, which means PA equals to 80 minus 5 times 6, which is 50. While PB equals to 180 minus 20 QB, which means 180 minus 20 times 4 equals to 100. After getting the total quantity and price of each market, we can find the maximum profit by using the formula pi equals to 80 QA minus 20 QA minus 5 QA squared plus 180 QB minus 20 QB minus 20 QB squared minus 50, which also equals to 80 times 6 minus 20 times 6 minus 5 times 36 plus 180 times 4 minus 20 times 4 minus 20 times 16 minus 50, which is the total is equal to 450. For number 3, a company produces a product with input X. The output is shown by the product function Q equals to 75 plus 5x squared minus 1 per 3x to power of 3. If the input price X used is 2,100 rupiah per unit and the output price per unit is 100 rupiah, how many units should be produced by the company to achieve maximum profit? What is the average production rate? So Px equals to 2,100 and PQ equals to 100. Q equals to 75 plus 5x squared minus 1 per 3x to the power of 3. So MP equals to derivative of Q, which is 10x minus x squared. The maximum profit of producer is MP equals to input price per output price. So 10x minus x squared equals to 2100 per 100, which also means 10x minus x squared minus 21. And we should switch the place into x squared minus 10x plus 21 equals to 0. And we get x minus 3 times x minus 7 equals to 0. So we can get x1 equals to 3 and x2 equals to 7. M equals to derivative maximum price and per derivative of x equals to 10 minus 2x, where M equals to derivation of MP equals to second derivation of Q. For input x equals to 7, then M equals to 10 minus 2 times 7, which is negative 4. For input x equals 3, then M equals to 10 minus 2 times 3, which is 4. So the input used for maximum production profit is 7 units, and the total output that are produced is Q equals to 75 plus 5x squared minus 1 per 3x to the power of 3, which also means 75 plus 5 times 7 to the power of 2 minus 1 per 3 times 7 to the power of 3, which equals to 200 times 202 per 3. So the output produced is 205 units. For the average production rate, we can calculate with the formula of AP equals to Q per X equals 205 per 7, which is equals to 29 and 2 per 7. So the average production rate is 29 units. Next is number 4. The supply function of a good is indicated by QS equals to 0.0125p minus 25. If the price is 10,000 rupiah, then what is the elasticity of supply for the good? QS equals to 0.0125p minus 25 equals to 0.0125 times 10,000 minus 25, which also equals to 125 minus 25 and equals to 100. E equals to derivative Q per derivative P times P per Q equals to derivative of QS times P per Q, which equals to 0.0125 times 10,000 per 100, which is equals to 1.25. So the elasticity of the supply for the good is 1.25. Next is the last number, which is number 5. In a closed economy, the household consumption of function is C equals to 50 plus 0.75y. The private investment is I equals to 25. The government spending is 40. The national income is Y. This condition shows an economic multiplier of C equals to A plus BY. And S equals to negative A plus 1 minus B times Y. So from there we can get A equals to 50 and B equals to 0.75. So we can find the MPC, which is equals to B. So it is 0.75. While the MPS is equals to 1 minus MPC. So the MPS is equals to 1 minus 0.75. So the MPS is 0.25. So to find the multiplier, we use the formula of K equals to 1 per MPS. K equals to 1 per 0.25, which equals to 4. So the economic multiplier is 4.